like 3.8, 3.9 billion years old. And you see two things that are key. One is you kind of see this river channel coming in through here like this and breaching the wall. There's a crater wall. You know how craters go, you smack a crater in, it gets walls on the outside. There's high walls all the way through here. It breaches the wall and looks like it flowed into the crater itself. And then there's something, I'll show you this in detail in a minute, there's something that if you're a geologist or someone who likes to stare out the window as you fly across the country, looks like a delta. It looks like a place where water or sediment and water flows into a big standing lake. Another really key thing is on the other side of the crater. Here's again, crater wall, crater wall, crater wall. Whoa! There's water flowing out the crater wall. This whole thing, 3.7 billion years ago, again, 3.7 billion years ago, where we have almost nothing on the Earth at all. This whole crater was a lake. It was covered in water. We think. So one of the things that you need to know is, one of the things you need to do if you want to try to study these things, understand the origin of life in a place like this, you need to go there and first make sure that you know what you're talking about. Was this really a lake? You know, we see these things, but you know, it's easy to make up stories when you see things. But you fly there and you land there and you can really understand what's going on. Here's an image that's sort of astounding. This is on the way down to land in this crater. And here's this thing that looked like the delta again. And the way a delta works is that the top of this thing would be where the water level was, and this would be where the sediment comes down. But let's see if this is really true. So we land in this crater and start to drive around and look to see what's there. And one of the most, this is, you might not believe it, but this is one of the most astounding pictures from Mars. Okay, it doesn't look that exciting, but check out these flat layers on top, things that come down just like this on a constant slope like this, and a flat layer down here. What is that? That's a picture right on the side of that place that we think might be a delta. Therefore, we think this might be a lake. And it looks like this. Why does it look like this? Well, here's an experiment you can do in the lab for entertainment. This is a layer of water. The water is right here, and there's sand coming down right here. And every once in a while, we throw in a little black sand just to make it, you can see what's going in. So you're going to watch water and sand come down like this, hit the water, hit the layer of water right here, and then build structures in through here. So let's go. Sand is coming in. You see the sand, it hits here, and it goes out, and it goes out, and it goes down like this. See how it goes down like this? As it continues to build, it continues to move out, and it looks just like that. Do you know why it looks like that? Because it's a freaking delta, that's why. There was a lake in this crater on Mars 3.7 billion years ago, which is, let's just all stop for a minute and think, oh wow, there was a lake in this crater on Mars 3.7 billion years ago. If you want to understand the origin of life, maybe you should go to a crater that's 3.7 billion years old and start to understand what's going on. So this rover, not the one that you heard the talk from in 2015, but the second one that landed during the pandemic, its job is to go actually collect samples. What we really want is to pick out those samples, bring them back, understand the chemistry of that environment. Was it conducive for life? But not just understand the chemistry, actually literally see if there were things that were alive in these. We're bringing back the samples in these little tubes that look like this, and here's an actual picture on the surface of Mars. The tubes they basically drill in to the surface of Mars, core the material gets packed inside kind of like this, and you can see one. This is an actual picture of a rock that was collected on Mars. And I'm really excited to show this next picture, which again, maybe it's not the most exciting picture of Mars, but it is to me. Here's the most exciting picture of Mars, which is, this is on Mars, there's the rover, there's the wheel. There's a sample. That might be the first sample that comes back to Earth. It got dropped on the surface of Mars in December, just this last December. And it will eventually, this one may or may not, because we're very careful about leaving many different samples in many different places, just in case, but one collection of samples, this location will get a big collection of samples. It's this crazy idea, but you know, at JPL, crazy ideas become reality. Here's the crazy idea. Collect these samples, do these cores, send another rocket, which then has another rover which goes and picks up these cores, or maybe helicopters, because we now know helicopters work really well on Mars. Pick up these cores, load them on a rocket. That rocket launches into space, goes into orbit around Mars. Okay. Anybody think this is crazy yet? Of course it's crazy. But the entire idea, which works really well, is crazy. Goes into orbit around Mars, then we send another rocket to go bring those from Mars back to the Earth, and then we drop them on the Earth. What happens? We drop them on the Earth, they land. This could be next door. I don't know where they land. I think they land in Utah. A desert in Utah. The samples, those little sample tubes were there. They people in bunny suits take them out. I only recognize this from, what was that movie? Oh, right. Which one? Andromeda Strain, that is not the one I was thinking of, but you're absolutely right. They did that in Andromeda Strain too. The Amy Adams one. Come on, Dreads, help me out.
Mars or Earth or something.
Encounter? Doesn't matter. Okay, bunny suits, and they pick out the rocks, and then they pick out things that look like this, and we say to ourselves, is that life? Is that not life? What is that? And we bring them to the lab, but you know what? We don't bring them to this lab. You know why? We do not have the technology to pick up rocks and look at them and understand whether that thing from 3.8 billion years ago is life or not life. So we are at the same time as building these missions that are going there, collecting them back.
Arrival.
Yes, thank you. It's like I knew it. It's a great movie. I really loved it.
Arrival.
It was like a tear fest too. Oh my God. This lab would not answer the question. This is a real lab at Caltech. My friend John Eiler runs it, and when I put the big red X on it, he kind of looks sad. But John is the smartest guy I know, and I know a lot of smart people. And he is building. He's basically building the machine that will answer the questions. He will bring back these rocks and not just be able to say like, yes, this little thing was alive or not, but be able to map out the entire chemical networks that all these things are doing. It's an amazing set of machines that he's building right now that I can't wait to see what he does there. Okay, so I'm going to switch gears very quickly and talk about one more thing, which is, again, we were talking about Mars now. There's a big problem with Mars. If we find life on Mars, it may have just come from the Earth. It is not impossible that if early on in the history of the Earth got hit by a meteorite, material flies up into space, flies around space for a little bit, lands on Mars, and if Mars, as we know, Mars had water at that point, it was warmer at that point, maybe life on Mars came from the Earth. So maybe understanding the origin of life on Mars, really we're just kind of going back and looking at ourselves in a mirror. Or even worse, or better, or I'm not sure which. In many ways, it actually is easier to figure out how to form life on Mars. Mars was warmer and wetter at a point when we think the Earth was actually frozen. And so maybe life formed first on Mars, meteorite hits Mars, lands on the Earth. We grow up here, and basically, we're going back and seeing our parents when we go back to Mars. Again, crazy idea, but this is a serious idea that's been proposed by another of my colleagues at Caltech, Joe Kirschfink, and it's very difficult to think of any reason why that couldn't have happened. And so this contamination between these planets that are really close in is hard to deal with. So what we really would like to do to understand if life is easy to form, hard to form, something else, is to find a place where there's no chance that contamination from the Earth or Mars could have gotten. And the place to go is Jupiter. Constantine talked a lot about Jupiter. Constantine showed you my favorite picture of the satellites of Jupiter. And my favorite satellite of all the satellites, well, Io is really interesting. Io is full of volcanoes. Nothing interesting life-wise going on there. Ganymede and Callisto, you can kind of even see are old and ancient critters. Europa's weird. Europa is a place that I think we need to really be paying careful attention to and thinking about if there is a chance of understanding the origin of life at Europa. This is the picture you saw at the very beginning as you were walking in. Europa is crazy. It's ice, it's an icy shell, and it's got these cracks, full of cracks and weird things. Here's a close-up view. It's got these cracks that are always weirdly colored. It's got melty-looking things that have come up through there. We don't really understand how all these things happen. And it's got these one set of regions that I want to show, which is right in here. Like at this scale, just look at a jumble, but it's a red jumble of stuff. At a closer scale, I don't have it in color because this is a JPL mission, a Galileo mission that flew to Jupiter and took pictures of all of these. So I mean, it's just kind of true that anytime you see really good pictures of things in the solar system, probably it was a JPL spacecraft that flew there. This is my favorite picture. I have a lot of favorite pictures, apparently. This is, if you look really carefully, each of these little blocks looks like, you can imagine it's an iceberg that broke off, floated away, and then refroze. You can even see, here's one that's cracked in half. Here's one, you can actually, I did this once and I can't do it on the screen without getting in trouble. You can cut these out and re-put them together over here. But they basically all broke off this section, went out through here and refroze in through there. This really tells you that there's something going on that heats and there's water going on there. We now know that Europa is a shell of ice and a huge ocean of water underneath that shell of ice. In fact, there's so much water on Europa that if you take all the water on the Earth and put it into a little ball, it looks like that. If you take all the water on Europa, it's bigger. There's more water in the oceans of Europa than there is in the oceans of the Earth, which is really a staggering thing, if you think about it. So, really, what you would like to think about is what is going on at the bottom of this ocean. It's true that this is an ice shell. There's no life in the ice shell. There's no life making its way through the ice shell. But the bottom of this ocean could be a really fascinating place. If you look at the bottom of our oceans, and particularly where the plate tectonics is active, where places are spreading apart, you see these things they're called white smokers. Hot water is coming in through here, minerals are coming in through here, nutrients that things can use are coming in through there, and when that happens, you get things like tube worms. This is at the very bottom of the ocean. Beautiful tube worms, unconnected to the photosynthesis happening above. You get little octopuses, which is astounding, and without a doubt my favorite. You get this guy. He's mad. This is the first light he's ever seen in his life. Someone just took a picture of him and he's mad. But you know what happens if you look at a place that's not where you're spreading apart? You know what it looks like? It looks like this. This is not the most interesting picture of the bottom of the ocean. This is boring. Most of the bottom of our ocean is incredibly boring, and nothing's going on there. And there's some life in there, but it's just dead. And we don't know which one of those is Europa. Is it vibrant at the bottom of the ocean? Is it dead? One of the ways we're trying to find out is understanding what the composition of the ocean is. We can't go there yet, but sometimes the water melts up through the surface in those places you saw and shows up here, turns red. Maybe it even sprays out like this. So if we can find these spots, it's a really interesting place to go. Here's Europa again. There's two sides. They're different colors. I'm sorry to say this is a little washed out, so you can't see it. If you could see it really well, there's a big yellow patch right here. This side of Europa, maybe not so interesting. It's getting bombarded by the volcanic stuff coming from Io, and so it's red, sulfur. I'm not going to tell you what's in the interior of Europa, but this patch right here, which is differently colored, it's that stuff where things have overturned. It's a really interesting place to go look. So we took a look at it with my third favorite telescope, the Hubble Space Telescope, to try to see what this patch was made of. The answer is that patch, which is clearly water ice with some stuff coming from the interior. That patch of material is salt. Like salt, table salt. Okay, sounds boring. I have this box here. You can hold up that. So this box of salt is literally standing right here, which we can taste later. Because you might say, okay, you said it was yellow. Salt is not yellow. We all know this, but salt becomes yellow if it is bombarded with radiation. And at Europa, it is one of the most intense radiation environments in the solar system. And that salt if you just do a little bit of radiation, goes from this. I literally did this yesterday just for this experiment, just to show you. This is just regular salt. I irradiated it with gamma rays for 3-4 hours, and it turns this color, which is now what it looks like. You know, so anybody who wants, if you want to see what irradiated salt looks like, here it is. Also, just tastes like salt. You might think you shouldn't eat irradiated salt, but only because you shouldn't eat salt. It's actually perfectly fine. So now we know. Okay, it's salt. Great. Is that interesting? It is interesting. You know, we like, okay, the Earth's ocean has salt, big deal. But the Earth's ocean has salt because of all that interaction with the surface area and with the bottom. It's a good sign that something interesting is going on. Let me show you one more thing, which is I'll admit, this is my favorite telescope today. This is the James Webb Space Telescope, launched a little over a year ago. In December of last year, just this last December, we finally got to point it at Europa. Now, it's a big telescope, but it's still pretty far away, so you don't get really detailed images like you get from all these JPL missions that are going there. But we got one thing that was really cool. This is that same region that's yellow that has the salt in it, and this is a map of where there is carbon dioxide in the ice. The same region that's been resurfaced has salt, it has carbon dioxide, and that tells you, I have no idea what that tells you. But we're trying to find out. So here's, my students are in the lab. I hope they're in the lab right now. I'm gonna call after we get back, make sure they're still in the lab, working hard. They're in the lab right now trying to understand what happens with ices, salts, carbon dioxide. I think it might be that you have organic material, bugs, who knows what, organic material in the ices getting irradiated, turning into carbon dioxide. It's a pretty exciting thing. JPL is sending another mission to Europa to really map this out in detail. It's going to launch in a couple years, be there a couple years later. It's going to be a very exciting mission from Clipper. But the real dream, I'm gonna end on this real dream. The real dream is a mission a little bit further in the future that goes something like this. You drop it off from here, it lands on the surface of Europa, because what I really want to know is what is actually happening inside the ocean of Europa. Find one of these cracks, you can see it's kind of red like we know it is, finds a smooth spot, lands right there, and how do you get to the bottom of the ocean? Well, you build your big thing here, you light a nuclear pile, and you start to just melt your way down. We do this in Antarctica for glaciers right now. We can do this now. There's a little tether for the radio system that goes there, and when you get into the ocean, your capsule opens up and spits out a tiny little submarine. The tiny little submarine we now have, these are being tested at JPL, little things like this that can be autonomous and fly around. You get to the bottom, you see things that are maybe like the bottom of the Earth, and maybe not, but on this particular case, you go around, you look enough, and you see these guys. Clearly, this is going to happen, right? We know this is true. This may not be true. But this is the hope, this is the dream. This is a few decades down the road, but I think understanding the ocean of Europa is really the key to understanding the origin of life in our solar system and planetary system. And I just want to end with one last thought, which is really, to me, it's how much fun this is to work on at a place like Caltech. A place like Caltech, it's a small place. You hear about it a lot because it's got huge impact for such a small place. The benefit of being such a small place is that you get to interact with everybody. You just heard a talk from just the two of us that included sort of all these different things. Planets around other stars, Earth history, extreme environments, bottom of the ocean, early Earth, evolution, origin of life. These things, in most places, they would be siloed into individual departments. The people wouldn't talk to each other. At Caltech, we have lunch together. We have, you and Andrew Howard sit around and talk about little planets. We talk about all these other things. It's a fantastic place to do this. And to really make this happen, we have just in the recent past started what we call the Caltech Center for Comparative Planetary Evolution, which really does blend all of these different things into a set of scientists all trying to understand how planets put themselves together, how life emerged on Earth, why we're here. And I think this is something that's fascinated humans forever. But I think that actually we're going to answer these questions. I think these questions seemed unanswerable even 10 years ago, and I think if you just wait a few more years, we're going to actually finally know the answers to why we're actually here, like Constantine started at the beginning. So, thank you.